Okay, so hello to all my virtual students, quarantine students, and remote students. I'm sorry that there was no sound on the video. I don't know what happened because the mic worked the rest of the day, but so here's the new video anyway. So just a couple of announcements before I start this. Being that so many of you are quarantined, I don't want to give that test next week. I just feel like that would just be a mess. So what I told the kids in class today was, we're essentially done with Unit 4. We were just going to spend a couple more days reviewing to get ready for the test, so I'm going to cut that short. And the Unit 5 packet is online, so if you're not coming into school tomorrow, just go online, go to Google Classroom, go down to Unit 5, you'll see the notes packet, and you can print that out, and we're going to work out of there. Unit 5, except for what we're going to be doing today, tomorrow, and maybe a little bit the next day, after we get beyond those 2.5 days, you're going to see that it's very similar to all the derivative stuff that we've been doing, the increasing, decreasing, maxes, mins, and concavity, and all of that. So what I decided to do, and you can see it, it's already up there on Google Classroom, I altered the assignment calendar. And your tests are going to be the 2 days right before Thanksgiving break. It was the best that I could do. I don't want to give it to you like the first day that you come back after Thanksgiving break. And I also don't want to lose momentum because I want to make sure that we get through everything for that AP exam. So that test that you're going to take is going to be a combo deal. I just made it this morning. So it's going to be a Unit 4 test and a Unit 5 test. So 4 questions on that test will be from Unit 4 material, and 4 questions on that test will be from Unit 5 material. Okay, so it's only 8 questions. It's no longer. You'll still be able to finish it in a class period. But half of the questions will be Unit 4 and half of the questions will be Unit 5. What I'm going to do is I'm going to grade them separately. So the first 4 questions, I'm going to grade those, and that's going to count as a test for Unit 4. And then Unit 5, those last 4 questions, I'm going to grade those and count that as a test for Unit 5. So you're going to get 2 grades on that test the day before, or the 2 days before Thanksgiving. A Unit 4 test and a Unit 5 test grade. Okay? Now, I didn't explain this to the kids that were live and in class today because I didn't get a chance to. You're still going to get the option for the 2 Delta Math bonuses. The Unit 4 Delta Math bonus that maybe some of you started or completed or you didn't get a chance to start yet, you can still work on that one, and that will go towards your Unit 4 test. I have to double check if the Unit 5 bonus is up there on Delta Math, but it should be soon. And you can do that, and that will apply to your Unit 5 test. None of this will be cumulative. It will just be stuff on Unit 4 and Unit 5. Just because I'm testing on 2 units, I'm not giving you any review material from Unit 1, 2, and 3. Okay? I'm still going to have you study for the Unit 4 test by looking at that Unit 4 review sheet that you have already in your possession. Just any of the questions that are not Unit 4, like the review of Unit 1, 2, and 3, disregard them. We're not going to go over them. Okay? And we're going to have days built in for review, so I'll go over all of this. And again, the Unit 5 test, nothing will be review. Okay? I think that pretty much sums up everything. So I'm going to get to this mean value theorem here. Okay. So if you look here, if at any point in time, let me just say, if you have any questions, just, shoot me an email, okay? And thank you again so much for telling me that I had no sound. Okay, so mean value theorem. So it states that you have a function. Now that function has to be continuous on a closed interval. So look at this picture right here. So here's the function. This is the curve right here. And you can see it's continuous, right? If you go from A all the way to B, it's continuous. There's no holes, there's no jumps. And then it says that it's differentiable on an open interval from A to B. In other words, the derivative exists. So what I said to everybody in class today was, like, for example, let's say I had a picture of the absolute value, right? And this was f of x. So that function's continuous because there are no holes, there's no jumps or anything. However, it's not differentiable because you have a peak or a cusp right here. Okay, so in this case, this would not be differentiable and we couldn't apply the mean value theorem, but we'll get to that. All right, and it says, then there's at least one number C between this interval from A to B. Now notice it's open, not including the endpoints, such that blah, blah, blah. Now let me explain what that means. So basically all that means is this. Do you remember back in 8th grade when you did slope, you had 2 points, right? And then you did y2 minus y1 over x2 minus x1, and you found the slope of that line. Well, guess what? That's what this is. This is y2 minus y1 over x2 minus x1. And when you do this, you've got the slope of that line. Now this says derivative, doesn't it? At some point C. So what this is saying, take the function, look at point C, and remember derivative means slope. And we're going to see something about the slope. So look, here's point C. The derivative is the slope at a certain point. Do you see the slope of this tangent line here is the same as the slope of this line right here? That's what this is saying. The slope of the tangent line, aka derivative, is equal to the slope of that line, which is this right here. That's your mean value theorem. Okay, now you may kind of grasp that, but you're really not. So I'm going to show you an example, and I'll show you how it goes. Here we go. All right, so turn the page. You follow along in your notes. Okay, we're going to do number 1. All right, so listen, whenever you have a fraction, the very first thing you want to say is it continuous? Because usually if you have a fraction, you're going to have a point of discontinuity. And right here we do have a point of discontinuity at x equals 0, because that makes the denominator of that fraction undefined, right? But here's the thing. X equals 0 definitely makes this function not continuous at x equals 0. But look, x equals 0 isn't in that interval. If x equals 0 was in this interval, we would be done, and we would say we can't apply the mean value theorem because x equals 0 is in that interval, but it's not, so we can keep going. So the very first thing you always check for, first step, is the function continuous? And the way you're going to basically do that is if there's a denominator, see what value makes it undefined, and see if it's in that interval. Okay, all right, so we did that. The next thing we're going to do is we're going to take the derivative. So we're going to take the derivative. Now the derivative of 5 is just 0, right? Now remember, this really is minus 4x to the negative first power. So that's going to be positive 4, right? Positive 4. X to the negative second power, which is really just x squared, right? Okay, so if something's differentiable, that means its derivative's denominator may or may not be equal to 0. So wait, let me restate that because I don't think I said that properly. If something's not differentiable, the derivative's denominator would be equal to 0. So similarly to the function, here, the value of x that makes the denominator equal to 0 is 0. So when I plug in 0 here, I get an undefined fraction. I can't have that. But again, x equals 0 is not in this interval, so we're good to go. So we just then keep going to the next step. So I'm going to repeat again. First step, check to see if the function's continuous. You'll know if you have a fraction, find the value that makes the denominator equal to 0 and see if it's in that interval. Do the same thing to see if it's differentiable. Take the derivative, see if there's a denominator, see what value makes it equal to 0, and see if it fits or doesn't fit in that interval. Now, we just passed through the first step and the second step. So the last step is you're going to take your derivative, which is 4, oops, thought my pen was on, which is 4 over x squared, and you're going to set it equal to f of b minus f of a over b minus a. I'm reading from the previous page, that formula. It was f prime of c, go back and look at it, f prime of c, that's this, that's your derivative essentially, is equal to f of b, which is going to be 4, minus f of a, which is going to be 1, over b minus a. Okay? All right, so let me just briefly talk. When they talk about a and b, that's your interval. The first number is always going to be your a, it's alphabetical, and the second number is always going to be your b. So all you're doing right here is you're going to plug in 4 into this equation. Then you're going to plug in 1 into that equation. And then you're going to just work this out. So take a minute and do that and see what you get. Okay, so I got a value of 1. So I'm going to go like this because I'm just going to cross multiply. So I have x squared equals 4. So then x has to equal plus or minus, because remember when you take a square root in calculus, we need plus or minus. X equals plus or minus 2. Now, I'm just going to rewrite this because I just want you to see something. So obviously that's a positive 2 and a negative 2. When you get these values, you want to check to make sure that your answers are in this interval, okay? And since negative 2 is not in that interval, that is not an answer. So this is the value. Now, if you read the question, the directions at the top of the page, it says determine whether the mean value theorem applies. We did that. And if it applies, state why it applies and find the values of C. So when you find your x equals 2, in this case, really what that is, guys, that's just your C value, okay? All right, so we're going to just keep doing more questions because I think the more you do them, the more it's going to sink in. If you're still teetering a little bit, just bear with me. All right, let's go to number 2. We're going to do the same thing. Well, look, we have a function. It is a fraction. The first thing we want to check for, remember, is it continuous? So we do have a denominator. So let's look. We know then the value that would make that denominator equal to 0 would be if x was 2, right? Okay, so we then say to ourselves, is that value in that interval? And in this case, it is, okay? So then, if that's the case, this actually makes your life easier. So since x equals 2 is, oops, that's supposed to be an s, is in this interval from -1 to 3, okay, comma, the mean, and you can abbreviate, value theorem doesn't apply. And check that out, we're done. So you kind of like when it doesn't apply because you have less work to do, okay? And it doesn't apply because that x equals 2 is in that interval. Done. Let's go to number 3. All right, so let's look at number 3. Now that's a sine curve. Hopefully you know that a sine curve is continuous because remember this thing goes on forever and ever and ever. So the function's continuous. So in that case, let's try the derivative and see if that's continuous. So remember the derivative of sine is just cosine. Okay, and hopefully you know that a cosine curve is also continuous. So we're not getting off so easy here like we did on number 2. So cosine curve goes on forever and ever as well, right? So that's continuous as well. All right, so now remember, if the first derivative is continuous and the second derivative is continuous, which basically means it's differentiable, right? You are going to then apply the rule. So the rule is f prime of c, which really is just cosine of x, right? Oops, cosine of x equals, and then we do f of b, which is f of pi, minus f of 0 over pi minus 0. So you're going to, at this point, you're going to plug in pi into the original function, and you're going to plug in 0 into the original function, and work this out and see what you get. Okay, so I got 0. So I have the cosine of x equals 0. Now just make sure that you understand what this means. This is saying the cosine of what angle is 0. The cosine of what degree measure is equal to 0. okay? And hopefully you know that x would have to be either pi over 2, which is 90, or 3 pi over 2. And I'm going to say this again. If you don't know that, you better start studying that. Now, remember though, once you get your answer, you've got to check these answers and make sure that they fall within this domain, okay, or within this interval. And 3 pi over 2 is 270, and that's 180. So this is not in the interval that was given. So we're going to just cancel that one out, and we know then that our C value would be pi over 2. All right, so let's look at number 4. Ooh, we got an absolute value here. Now remember, I talked about this at the beginning of the video. Now remember, since that number is inside parentheses, that's a horizontal shift and in the opposite direction. So that would be moving to the right 3. So that's what the function looks like. Now, is that function continuous? Sure is. So f of x is continuous. Now what we want to do is we want to figure out if f of x is differentiable, okay? And f of x is not differentiable. So it's not differentiable at x equals 3, right? All right, now, notice that I accidentally did not type in the interval. So this is supposed to be from 0 to 6. So if you would put that in there, because otherwise we can't do this question. Now, so that just made you a happy camper because x equals 3 is in that interval and it's not differentiable. So if that's the case, okay, not differentiable at x equals 3 and 3 is in this interval from 0 to 6. Oops, 0 to 6. Therefore, mean value theorem can't apply. All right? All right, let's move on to the next one, last one that we're going to do together. Okay, so number 5. I would simplify that. I think that's kind of ugly. So I'm just going to distribute that x through. So that's going to be x cubed minus x squared minus 2x. Now, guys, that's a cubic, and you know that cubics tend to go like down, like that, or they go up, up like that. Those are continuous, and there's no denominator here. So we can pretty much assume that that's going to be continuous. So let's go on and take the derivative and see what happens there. So the derivative is going to be 3x squared minus 2x minus 2, right? Now, that's a quadratic, the derivative, right? And, you know, a derivative, it could look like this, it could look like this, it could look like this, but those are also continuous. So we are continuous and we are differentiable. So we have to apply the mean value theorem, which states take the derivative and let's set it equal to f of b minus f of a all over b minus a. Okay, take a minute, work that out, see what you get. Okay, so I have it equal to -1. So I'm going to add that 1 over to the left-hand side. So that is going to give me -1 equals 0. And I know that I need to factor that. And that's one of the reasons why I wanted to go through this, because you guys are so stinking smart, but sometimes you forget how to do the basic factoring. Remember, this is rainbow. So we have to multiply to a -3, and that's a -3, and we have to add to a -2. So we drop down the first term, drop down the last term, and we say what multiplies to -3 that would add to -2. That would be a -3x and a +1x, right? So then we group. That's going to be 3x and x minus 1. And this is going to be, let's just take a 1 out of there, and that would be x minus 1. So we have 3x plus 1 as one of the factors, and we have x minus 1 as the other factor. So on the left-hand side, we have x equals -1/3, and on the right-hand side, we have x equals 1. Okay, so Now we just need to check both of these answers and see if they are within this interval. Now, x equals negative 1/3 is within that interval, okay? So we can then safely assume that one of our c values is going to be negative 1/3. Okay, now, about this x equals 1, do you see that that x equals 1 is the end point of the interval? If you go back, and I am not going to, I can't obviously scroll back in this kind of a video, but if you go back and look at page 2, I'm looking at it right now, the top of the page, the second line down, it says, then there is at least one number c in the interval, and look at that interval. It's an open interval. They took away the brackets. So that number c cannot include the endpoints. As soon as they put those parentheses there are no more brackets. You cannot include any endpoints in the interval. So what that means is this is an endpoint of this interval, okay? So what that basically means is that does not count. And your only answer for number 5 is c equals negative 1/3, okay? All right, so as I said to the kids that were in class today, your homework, and it's on Google Classroom, but your homework is to finish 6 through 10. Okay, 6 through 10. You do not need to do number 11. All right, again, I'm so sorry about the video. If it ever happens again, just give me a buzz. Take care, guys. Hope to see you soon.